And welcome to lesson 5 on solving literal equations. Well, a natural question you might want to ask is what in the world is a literal equation? Basically, a literal equation is an equation that has more than one variable. Another way of thinking of a literal equation is just basically a formula. So we are going to still use inverse operations and the properties of equality that we've been using to solve equations. We're going to continue using those to solve literal equations. The difference is our solution will be an expression. It's a mathematical expression in terms of the other variables. It's not just going to be a number answer. So we're basically going to mess around with some formulas and solve for some different variables, and our answer is still going to be like a formula. So let's take a look at what I mean by these. Let's go ahead and jump in. So our first step when we're solving for a variable is to locate the variable that we are asked to solve for in the equation. Okay, identify the variable. Once we have identified or located that variable, we need to figure out what operations are being done on the variable and what order they're being applied so that we can undo those operations. So we're going to use those inverse operations to undo and isolate the variable just like we've been doing with equations. So let's see what that looks like. So here we go. This one wants us to solve for x. So remember, the first thing I said we need to do is to identify that variable that we want to get alone. Okay, so we're going to try to get x alone. So the first thing we want to do if we're trying to get x alone, this one's pretty easy. The reverse order of operations is to add 5, right? Now the thing to make sure you're understanding is what things can go together, which terms are like terms and which ones are not. Bring down your equal sign and then just write what you have left on each side. This one I have a y term and I have a plus 5. It doesn't matter which order you write them. It could be 5 plus y. It means the exact same thing. And then I have that is equal to a negative 3x. Well, we're almost done. Negative 3 is being multiplied by x. So the opposite or inverse operation is to divide by whatever it's multiplied by. And we need to do the same thing on both sides. So don't be afraid. These are going to get a little messy looking. Okay, don't be afraid of that. Negative 3 divided by negative 3 is 1. And we have x alone. So whatever we get on the left-hand side here will be our answer. So I'm just going to rewrite what we have. We have y plus 5 divided by negative 3. This is our answer. Okay, notice we're not getting just a number. We're getting this other thing that looks like a formula. Okay, it's a mathematical expression, but we wanted to solve for x, and that's what we did. X is equal to y plus 5 divided by negative 3. Okay, the second one, we're going to be solving for r. So let's go ahead and locate the letter r so we can figure out what we need to do to get that one alone. So we're solving for r. We've got an r there and we've got an r there. So we need to get those alone. So in order to solve for r, first we need to get all of our like terms together on both sides so that we can isolate. So we have a 3r. There's nothing on either side to combine, so we just need to get everything on the same side. So let's go ahead and do minus 3r on both sides. I guess that's as good a place as any to start. If I subtract 3r from the left side, 3r minus 3r is 0, and I am left with a 2s, and a minus 7 is equal to a minus 4s. Plus 4r and minus 3r is plus 1r, and then minus 8. So let's go ahead and get our, remember we're trying to get that r term alone. Let me just keep that highlighted because that's the one we're trying to get alone. So the next thing we might want to do, let's go ahead and add 8 to both sides because he needs to get on the opposite side of where the r term is. So plus 8 and minus 8 add to 0. So I have a 2s, and then a minus 7 and a plus 8 is a plus 1, is equal to a minus 4s plus r. And again, we're trying to get r alone, so it looks like we have maybe one more step. Okay, we're trying to isolate that r term. This 4s needs to go, right? So right now 4s is subtracted. This negative 4s plus r would be the same thing as r minus 4s, right? That would mean the same thing. So the opposite would be to add 4s to both sides. So we're going to add 4s both on the left and the right. Okay, And then we're going to go ahead, let me extend my page here so we have enough room to work here. So minus 4s and plus 4s add to 0, so our r comes down. Here's our equal sign. 2s plus 4s is 6s, and then we still have a plus 1. So this is our final answer, okay? So r is equal to this expression, 6s plus 1. So again, you're not going to get number answers. You're going to get answers that are still equations. This one says the formula C equals 5/9 F minus 32 expresses Celsius temperature in terms of Fahrenheit temperature. Solve the formula for F, then find Fahrenheit temperature when Celsius temperature is 25. So we have a two-part problem here. First thing we want to do is we want to get F alone, right? So let's go ahead and rewrite that equation. Okay, so we have C is equal to 5/9, and then we have F minus 32. Not a very good subtraction there. There we go. So I left a little space here because I know we're going to have to multiply by the reciprocal of 5/9, which is 9/5. But remember, whatever I do on one side, I must also do on the other. So once I multiply by 9/5, these 5's cancel and become 1's, and the 9's cancel and become 1's. And I just have F minus 32. So I don't need the parentheses anymore. And over here I have 9/5 times C. My goal is to get F alone. So F is being subtracted by 32. So we want to get rid of that minus 32 and we want to add 32. Okay, so we want to add 32 to both sides. Now, when I do that on the right, they add to 0, and I just have F alone, which is what I wanted. Now, on the left-hand side, don't make sure that you understand that the 32 doesn't have a C with it, and the 9/5 is multiplied. So those terms don't combine. So I'm just going to write that as 9/5 C. It's 9/5 times C plus 32. Okay, they don't combine. You just have both of them there. So I've done the first part of the problem, which was to solve the formula for F. We did that. So the second part of the problem says we want to know what the Fahrenheit temperature is if the Celsius temperature is 25 degrees, right? So let's go ahead and plug in 25 for C and see if we can figure out what the Fahrenheit temperature is. So that says take 9/5 multiplied by whatever C is. Now C we said is going to be 25. I'm going to write that as 25 over 1. And then it says plus 32 equals F, right? So what I can do is I can cancel between the 5 and the 25. 25 divided by 5 is 5. 5 divided by 5 is 1. And then 9 times 5, I'm going to extend my page here. 9 times 5 is 45. Plus 32 equals F. Well, if we just add those two together, we get F is equal to 77 degrees. Excuse me. All right, so the formula for the area of a rectangle is area is length times width. I'm sure most of you probably already know that. If a rectangle's area is 64 square centimeters and the width is 16, what's the measure of the length of the rectangle? Well, we're going to start off with area equals length times width, right? And let's substitute what we know. It says that the area is 64, and it also says that the width is 16. So let's go ahead and substitute in what we know. So instead of area, we want to write 64 equals, and instead of width, we know the length, or we don't know the length, excuse me, but the width is 16, right? So instead of width, we're putting in 16. So now we're trying to solve for L. L is being multiplied by 16. So we want to do the opposite, which is to divide by 16. Divide both sides by the same number. That's our property of equality. And we get the length is equal to 64 divided by 16, which is 4 centimeters. Correct answer, yay! And our last slide, the Chu family is taking a camping trip. They live 176 miles from the campsite. If they travel 55 miles per hour, how long will it take them to reach the campsite? I've given you a little hint here. We want to solve the distance is rate times time. for time. So we want to know how long. So that's kind of an indicator. How long will it take? How long will it take? Okay, so that's t, that's time, right? That's what we're looking to solve. So let's go ahead and solve this for t. So if I have d equals rt, to get t alone, I need to divide both sides by r because it's being multiplied, right? So the r's cancel, and I have t is equal to d over r. So it's distance over rate. So let's figure that out. So the time it's going to take them is going to be the distance they travel divided by the rate of speed. Well, the distance that they travel is given in the problem, right? The distance is 176 miles. That's D. Ooh, that's kind of dark. Sorry about that. And the rate that they travel is 55 miles per hour, right? So let's substitute those in. So that gives us 176 is their distance divided by 55. And if you punch that in on your calculator, that'll give you the amount of time in hours. So 176 divided by 55 comes out to be 3.2 hours. And if I go ahead and click on my lovely little tent down here with the campfire, I get the correct answer. So that'll do it for literal equations. See you next time.